Hi, my name is Tom Coolidge, and I'm ESRI's Pipeline Industry Solutions Manager. I'm facilitating today's webinar along with my colleague, Jeff Allen. Jeff is ESRI's Global Pipeline Practice Lead. On behalf of both of us, welcome to our focus on how you can best use ESRI Pipeline Network Management capabilities on PODS 7. I hope you'll find our time together today to be interesting, informative, and helpful. Before we get started, please take a moment to note the webinar control panel on your screen. I would like to encourage you to post your questions as they occur to you during the presentation in the GoToWebinar Questions dialog box. We will answer as many questions as possible as time permits after the webinar. Questions requiring longer answers and some technical questions that are better answered by one of our specialist colleagues will be handled individually afterwards. Please also note you can switch between telephone and computer speaker audio and adjust your view to full or partial screen. And again, please note today's webinar is being recorded. Now, please welcome my colleague, Jeff Allen. Jeff?
Thanks, Tom, and thanks everybody for joining in this morning, this afternoon, depending on where you're at. This is actually our third and last webinar for the year. We've been on a pretty good cadence of doing one of these webinars every quarter, with the third quarter being our face-to-face pipeline seminars in both Houston and Denver. So from a planning perspective, we're going to try to do the same cadence next year as well. So there'll be 2 webinars in the first and second quarter. So if you have questions or if you have interesting ideas that you'd like to hear next year, please feel free to think about those and pass them along to either Tom and I. But for this last webinar for this year, what I wanted to do is kind of focus on how we can use some of the pipeline data management tools that ESRI has in combination with the new PODS 7.0 release. I've been active in PODS for a number of years, was on the technical committee for PODS 7.0. And we really worked hard to sort of revisit all the tables and revisit the design of PODS for the PODS Next Gen release, which is now out. And so what I want to show you today is how you can actually leverage PODS 7 and natively edit that with ESRI kind of out of the box pipeline tools. So from a pipeline perspective at ESRI, we've really been focused on, kind of modeling this entire supply chain. Right, pipe is pipe, but we have different modeling techniques that we might use, whether if that pipe is in the upstream space, whether it's onshore or offshore gathering, maybe it's in that transmission, our traditional midstream space in the gas and liquid transmission, or maybe it's inside these facilities, right? So more and more operators are saying, we need to go inside the fence these days, and how do we pull that off? And so I kind of want to show you a couple of techniques today on how we are approaching this within the ESRI technology and how that all ties back into storing this system of record information back in PODS. So if we look at how we've been leveraging location analytics or location technology across the pipeline organizations, we see lots of different use cases. And what we're really going to be focusing on today is what we traditionally see as our asset management or mapping department. This is where the GIS typically grew up from, started as mapping, generating alignment sheets. But really, we now see this as the organization that's responsible for that single version of the truth about where assets are in the field and all the information about those. And we see still the largest consumer of that data being the pipeline integrity group. They often need all that information for risk calculations, HCA class, running integrity programs as well. But the other group that we see now heavily leveraging this GIS data is asset operations. So taking that data that we've been maintaining in that corporate GIS and moving it out into the field and really enabling workflows in those inspection pieces. And then the other part of the organization we see sort of taking a lead in leveraging GIS is on the upfront asset development. Obviously GIS has been heavy into the planning, but we now seeing things, leveraging those same mobile tools and the right-of-way engineering design and as-built construction efforts. So if we kind of take a step back and we look at that entire supply chain from the wellhead to the meter tip, and everything in between, a lot of us have been trying for years to say, how can we put all that data in a single enterprise geodatabase, regardless of where it is in that supply chain diagram, and regardless of how we're modeling that. So the way that we have approached this at ESRI is we actually have two pieces of software that we would deploy to solve that problem. So that enterprise geodatabase, which would have that PODS 7 data model inside of it, would have two pieces of software tools sitting on top: ArcGIS pipeline referencing to handle the linear referencing components, and now the new utility network, which would handle that connectivity model. How are things connected together? How do we do tracing? How do we do flow analysis? And how do we model pipes that don't fall into that traditional linear referencing world? Right, those two tools sitting on top of that common PODS database now work together so we can manage that entire supply chain from the wellhead to meter tip in a single system of truth. The other big thing that you'll see in the change here as you start looking at these new tools is where we've traditionally had these client server architecture. We've had desktops directly connected to that underlying PODS database. We're now moving into the world where we see more web services architecture. So now the server takes a much larger role in this ecosystem, and we're publishing out web services that can be editable not only from the desktop, but from web interfaces and also connected mobile devices. So we kind of freed up that editing environment from just being a desktop-only interface and moved that out into these other platforms as well. The other advantage we have is because that web server now kind of is the traffic cop of data flowing into that underlying PODS database, we can now implement a rule base that makes sure that as data goes into the server, it not only meets the sort of GIS topology rules, but also passes business rules and business validation as that data gets stored in the backend system, regardless of where it's coming from. So what we'll do first is take a look at the linear referencing component. This has been the traditional space where we've deployed PODS databases in the past. And probably, I would say 90% of the customers that use PODS sort of have a linear referencing as a background or requirement to modeling their pipeline data. And so just to kind of set the stage here, when we talk about linear referencing, we're really talking about enabling point and linear events to reside on top of a measured route. And typically those measurements, not always, but typically those measurements represent the amount of steel that's in the ground, the measurements along that pipeline. And we typically put all these point and linear events in, reference those to that underlying route by their measure, so where they stop and start or where they live. And as the route manipulation happens, as the route moved, those point and linear events stay glued to that underlying center line, right? That's the primary driver of the linear referencing tools from a modeling technique. And so often people say, oh, we need linear referencing because we need to support engineering stationing equations. And that's true, linear referencing does support those things, but really at its core, it's a way to model pipeline data. And the reason we use linear referencing is because oftentimes, especially in these highly regulated scenarios where we have lots of data that we need to store on top of these pipe segments, as we start really layering in all this data, it's much easier to manage that data in kind of what I call the layers of the cake, right? So I split up my data elements, say my pipe, my coating, my valves, all the things that I have. And instead of breaking that GIS pipeline down into a million different pieces, I kind of model that data in its individual components on top as linear or point arranged events. But if I ever need to see that data all together for, say, some pipeline analytics, I would run an algorithm called the dynamic segmentation tool that would then take all those individual breaks of that linear referencing data, put it back together, and give me an output layer that has all that stuff combined back together so I can use it for my analytics. So this concept of dynamic segmentation is built into the linear referencing tools from ESRI. So as you manage your data in pods in those individual event tables, if you need to see them all back together again for an analytics, you would run our DynSeg tool, and that would be an output for you. So ArcGIS pipeline referencing comes with a couple of key components with the software. One is this information model, and I'll explain what that is in a little more detail. But those are the key columns and attributes that the software tool is looking for within any pipeline database. And we were fortunate enough to be involved in the design of PODS 7. So we've included the APR information model inside of PODS 7. So everything we need to make APR work is available in the model out of the box. Now, for the route editing and route manipulation, this is all going to happen in ArcGIS Desktop, specifically ArcGIS Pro. So those workflows for maintaining, calibrating routes all happen on the desktop tool by the GIS professionals, and I'll show you some examples of how those work as well against PODS. We also have a server extension. So what happens with that server extension is that when we now have data loaded into the data model through APR, we can now allow linear referencing functionality at the server level. So if I have a web app, for example, that I need to store some event data, or I need to locate a location along the line by measure, instead of having to replicate all that information or all that logic from the desktop, all that's sitting as a REST service on the server level that I can call. And one of the tools we actually deliver to you is a web application for editing event data. So instead of having to deploy a heavy desktop to your line of business folks, we can actually enable them to be able to go in and modify point and ranged events on top of the APR linear referencing using this web application that you can call directly from your portal. So those are kind of the big building blocks that you would receive as you were to purchase APR and implement it in your solution, your stack. Now let's dig into the data model components a little more, because this is really where the rubber hits the road relative to how we interact with PODS. And this screen is really important from an APR perspective, as well as understanding how the tools work with the underlying PODS data model. So we call this an information model because you'll see on this diagram, there's very little talk about valves and T's and taps. It's because we've designed APR to be kind of agnostic to the underlying data model. You can configure this to work in a number of different scenarios, and this is why it was easily kind of plug and played into the PODS model. So you will find these feature classes inside of the PODS 7 release. And so it really starts with the Centerline. So in traditional PODS, where you might have built up the lines from a series of calibration or control points, in the Geo Database implementation of PODS, it actually starts with the Centerline geometry. And so this is a line feature class that stores the position of the pipeline on the face of the earth. It can be 2D or 3D, so it supports both 2D and 3D polylines. And from there, we create what we call networks. Now, PODS can handle as many, or APR and PODS can handle as many networks as you'd like. Out of the box, we've delivered it with two networks, an engineering network for your engineering stationing, and a continuous network that would model that sort of continuous stationing along the lines, often useful for doing calculations where you don't need to deal with the equations. You just want a clean set of stationing along that entire route. So this basically allows you to have multiple M's on top of any pipeline network, right? So inside of those networks, there are routes, and a route can be, a route is a continuous section of pipeline with continuous stationing, right? So the difficult thing from a PODS and APR perspective is that a route would be equivalent to a PODS station series, right? A contiguous set of stationing along that line. So every time you have an equation along the line, you would have an APR route that would represent that section of pipeline. And we apply the measures of those engineering stationing to those routes through a series of calibration points, right? So here's where the control points come back into the picture. We place those calibration points or control points on top of those lines. And the interesting part of this, especially if you're coming from, say, the gathering arena, is we only need 2 calibration points, one at the beginning and one at the end for any route. Now, obviously, in the transmission space, we would have lots of calibration points, maybe even down to the weld level to tie. But the calibration point is basically a known location on the face of the earth that has a known measure. And anything else that's located by measure between calibration points is going to be spatialized by those upstream and downstream calibration points. So that's really what we need from the model's perspective to get APR to work. And the really configuration that we need to do is we need to tell the software where these key fields and these key feature classes live inside the PODS database. So as you deploy APR on top of PODS, there'll be a couple steps. One is creating a data model, and the second is kind of wiring that data model into the APR software. And so that's what I'm going to show you next, is how that happens. So we'll start with the configuration, and then I'll show you how it looks within the ArcGIS Pro environment. So if you want to get started, first thing you do is you'd go to the PODS website, you'd log in with your PODS credentials. Obviously, this is to access the PODS data model, you'll be a PODS member. So you can reach out to PODS if you're not a member and sign up, and they'll give you access. But once you have access to the PODS website, you'll go into the member-only area and download the PODS 7.0 package. And so this will have all the things you need to get started, including the definition of the PODS database and some tools to build a Geo Database from those delivery packages. So you'll download those PODS files, get them unzipped in your computer, and then really it's pretty simple from there. You create open up Pro, create a new project, and within that project, you'll reach out to those downloaded database files that you grabbed from PODS. And what you're going to find inside of there is a PODS toolbox, right? So PODS has delivered a couple of ArcGIS compatible toolboxes that allow you to get started and create the schema for you. So you'll go ahead and grab that toolbox and add it to your project. For those of you out there that are busily taking screenshots, have no worry. We're going to post all these slides when I'm done, so you'll have access to download these and review them. So no worries to take a whole bunch of notes here. This will be all made available to you guys after the webinar. But inside of that toolbox that you downloaded from PODS is going to be a Create 7.0 Geo Database from XML. So obviously PODS 7 can be deployed in a number of different configurations. So we're going to be focusing on the Geo Database implementation today. So from that, you would just create a new blank Geo Database. You'd point to that XML workspace that's also in that download, and you would set up some, what you want for a projection system that you want to use with your data. And those projections are going to set up a couple of key fields for you. The main ones being the M tolerance and the X and Y resolution. So these are key fields as you're setting up the PODS database with APR. And again, those are be pre-filled for you from this tool as you build those feature classes. So that's all you need. Once you run that tool, you'll be able to open up that file geodatabase. You'll have all the relationship classes, all the feature classes, all the tables, all the columns, all the definitions, all the domains that you need for PODS 7. And so at that point, the next step of the process is to get that sort of wired up to the APR software. So inside of APR, when you deliver and install that tool inside of Pro, you're going to get a location referencing toolbox. And within the location referencing toolbox, you're going to find a configuration folder. And in the configuration folder, there's going to be kind of 3 key things you're going to want to do. One is configuring the base linear referencing system, then adding the networks. In this case, we've added a engineering and continuous network, and then configuring all the point and ranged events. So this is probably the one you'll do most often. There's obviously lots of point and range events in the PODS model. You'll iterate through and configure and wire those up. If you want to create additional events of your own choosing, then you can create those feature classes yourself and then go back and wire those into APR using those same tools. So this is the key part. When you create the linear referencing system, which is that first step, it's going to create a couple of those key feature classes for you. And in this case, instead of creating them, we're going to want to point to the existing PODS feature classes and columns. So remember, from that initial diagram, there's a Centerline feature class, right? So when you configure the LRS from an existing data set, you're going to want to point to the PODS Centerline feature class, and the Centerline ID from APR is going to be pointed to the unique ID field. So you can kind of see how this cadence is going to go. I've outlined for you the feature class in a column and a quick screenshot of the APR configuration screen so you know how to wire these up. Next, you're going to wire up the Centerline sequence with its tables and its fields. That's an example of that there. The calibration point table and its fields. So you can see now we've got the calibration point measure. You will see as a pattern here, everything in APR is date sensitive. So we're often going to be wiring up the from and to dates with all these feature classes, things like network IDs and route IDs. We also deliver as part of the tool a red line, so you can pass red lines back and forth between the event editors and the desktops. So this is more kind of part of the software, but I show you how to wire up that red line feature class as well, so you can use it within APR. So those are the four key things you need to create the base linear referencing system, LRS. And once that is created, the next thing we're going to do is create a network, right? Remember, the network is where we store the routes, and you can have as many networks inside of a linear referencing system as you need. This is an example of the engineering network. So we've already got that defined in PODS, and its feature class is called Engineering Station Network. So you point to that feature class within the PODS data model. In the previous screen, I had called my linear references system APR. That's user definable. You can configure that name. But these are the fields in that PODS data feature class that you're going to want to point to. So the route ID field is going to the PODS unique ID. The route name field is going to the network route name. And obviously, when we built these within PODS, we wanted to make them sort of part of the PODS standards. So things like unique ID you'll find throughout the PODS model, but where we could adopt names from APR, we did. So things like the from and to dates are very clean. You can do things like include fields to support lines. We've done that here, and we've enabled that checkbox, and then some line iData. So the lines within inside of APR have a bit of the hierarchy, right? So inside of each route, routes can belong to lines and get rolled up, and so we've included that line support in PODS as well, and that's how you wire up that line support to APR. So when we've got the engineering network, we do that same process again, this time for the continuous measure network. Remember I said we have two networks delivered with PODS. So this is across those lines, you'll have a continuous or clean set of measures that take out the effects of the equations. So again, same process, you find that feature class inside of PODS and wire up all the individual tables to it. And then finally, once we've got the networks created, we would create all the point and linear events that want to participate with those networks. And in this implementation, we have all our events wired up to the engineering network. This is just a quick example of a point event. So here I'm configuring the valve. Now, obviously, the valve feature class is going to have a lot of different attributes associated with it. It's going to have valve size, operation type, MAOP, SMICE, all the things all the business columns that you'd expect from the valve. But really, because APR is sort of agnostic to this, the ones we're really interested in wiring up are going to be the things that are part of the linear referencing system. Again, those dates, the network ID, the unique ID, and the measure. And that feature class can have whatever else you'd like in it. If you have other attributes that you want to add to the valve, you simply add it to the valve feature class, and APR will just start managing that data. So there's nothing you don't have to go reconfigure your events if you add more business column logic to these events as you go forward. Same for your linear events, very similar, except now you'll see instead of a single measure, you'll have a from and a to measure, obviously because it's linear, and also a from route and a to route, because remember, linear events can span routes or span station series. So when we're entering linear events into the system, we're not going to be just giving it a single network ID, we're going to give it multiple networks along that route, or a from network and a to route ID and a from route ID as we place linear events. And then the last step is we've also delivered a couple of domain and cross-reference tables for you. So this is kind of more of the wiring or the plumbing for pods. And so there's an XLS table that has a lot of these domain columns within it. And there's a simple out-of-the-box tool from the ESRI side that allows you to take these metadata tables and domain codes and move them into your project Geo Database. So we have the main metadata, the domains, the values, and the cross-reference lookups that get added to the PODS model as the final step in the configuration. So at that stage, we've got the data model deployed. We've got a PODS data model deployed into the enterprise Geo Database, and we've now told APR, there's where all your key fields are. We've done that wiring, and that wiring is actually saved in a table, a configuration table within the enterprise Geo Database. So once you've done it, you can go back, you can modify it, you could do it again, and if you transport that Geo Database to another machine, or you load it up into, say, SDE, all those APR configurations are going to be moved over to that server as well. So I often start with a file geodatabase, do my configuration, and then move it up to the server when I'm happy with that. So what I'll do now is I'll just move over to my Pro desktop, and what you're seeing here is some of my sample data that we've had currently deployed for other demos, and I've just used some of our batch tools to move that into the Geo Database that I created. So if I just go to the catalog real quick, and if I go into my folders here, I've got this PODS 7 Geo Database, and if I open it up, you'll see all the feature classes and all the relationship classes in there. You'll see a feature data set, and this is where we really have all those different PODS feature classes that exist inside of here. So you'll see some ones that I had kind of called out. There's that calibration point feature class. There's the Centerline feature class. There's the continuous measurement, and then the engineering station network. These all existed in the core model, and now they've been sort of wired up to the APR software. And basically what I've done at this point is just drop those into my table of contents. So here's my engineering station network. I've given them some color coding based on status. I've got my calibration points, and for this example, I've got some valves and some linear pipe segments in my demo. So let's just take a look at the Pro toolbar. If you're not familiar with Pro, you can kind of see it's got that kind of look and feel of Microsoft Office, where everything's context sensitive. So as I add data to my table of contents, I'm going to expose more functionality within Pro. And in this example, I've got this location referencing tab that now turns on. So this is the APR functionality. And because I have an APR configured layer in my table of contents, this ribbon bar is now going to be exposed to me. So if I just now zoom down into the sort of gathering line here, I'm just going to show you a quick example of how easy it is to add a route, an engineering route to the PODS database. So you can see here, remember I said everything starts with a Centerline feature class. The Centerline is that geometry of where that pipe exists in space. And what I'm going to do is I'm just going to use the out-of-the-box editing tools, and I'm just going to go ahead and create a new piece of geometry for myself here. So I'll go ahead and snap into this existing line. I'll come down here and end it at this well pad. Now, obviously, this would come from existing geometry, maybe a Centerline survey or a legacy database that you would add. I'm just using some of the sort of heads-up editing tools here just to add this Centerline really quickly. So again, doesn't have any stationing, no measures. If I wanted to, I could have put Z on those vertices as well, but it's just a geometry of where that pipe, where that route exists in space. And now if I want to go ahead and create that route, I'll just go ahead and choose the center line. You can see it highlights it for me. It shows me the digitized order. If I wanted the stationing to flow away from the well pad, I could just use the out-of-the-box editing tools and flip the digitizing direction of the underlying center line. Once I've chosen that center line, I'm just going to hit the create tool. I'm going to create this in my engineering station network. Remember, everything I said is date dependent. So here's the date that this line is active. I'll give it a line name. I'll give it a route name. It's automatically grabbed the two-dimensional measure for me from the underlying geometry. So as the crow flew, or the two-dimensional geometry of this line is 6073. Now obviously I want engineering stationing. So this is going to be creating that end calibration point for me. So I'll drop that end calibration point at 60 plus 85. Now remember what I said, anything that's in the feature class is going to be shown up, is going to show up here in the software. So these columns up here are APR specific, but anything that I've got in that feature class that is required will show up here as required fields. I'll add this to my engineering station network, and let's give this a status of current. And any other attributes that you would want to store at the route level, you could just add to the underlying feature class, and they would then show up in this attribute list. I'll go ahead and hit run. That process is finished. You see that that red line now is enabled, so this is now part of my engineering stationing network, right? I can see the underlying center lines underneath it. And now if I turn on the calibration points, you'll see I have that calibration point at 0 and that end station at 6085. And if I wanted to now, I could go ahead and add additional calibration points to this line at known intervals. Maybe this bend here. Let's snap it right to that vertice here. Let's give this an engineering station of 70. And let's drop a calibration point here at my my elbow. So now I've got that center line in my system. I've got to get it calibrated, and now I'd move on and add any point or linear events that I need along that route. And you can see if I identify this route, you can see the linear interpolation. Say if I wanted to know what the station is of this crossing here, I can just click on the map, sort of X marks the spot for me, and you can see that that measure is 25 plus 33. So that's the linear interpolated measure of that geographic location along that center line route. So fairly simple, fairly easy. And again, everything in APR is time dependent. So I made that line active today. If I move back in time a couple of days, you can see that that center line doesn't exist, that route doesn't exist. And if I move back to today, there's that route from today. So that's the example of creating a route. Let me show you what this would look like if we were doing a realignment or a reroute on this line. So I've got another area along the pipeline I'll zoom to here. So here I've got a section of the pipeline. You can kind of see the new scar on the imagery here where I've got a reroute area. And for this particular example, I've received from survey data from the field. So I've got a bunch of shots that came in from the surveyor with the weld locations and major PIs and elbows for this reroute location. Now you also see down here, I've got an equation. So there's actually two routes here. This one route ends at 911 plus 95 at this valve assembly, and I've got a 0 plus 0, 0 going forward. So this particular reroute is going to actually span across two existing routes. We're going to retire this section, and we're going to add to this new section and create a new equation down here where we tie in. So remember, the key here is we need to get this center line geometry created first, and obviously all I have is some survey points. So one of the advantages you have is you have access to all the sort of underlying tools in the enterprise stack. And so for this particular example, I'm not going to use an APR tool. I'm just going to use one of my out-of-the-box tools that, let's see if it's my favorites here. No. I'm going to use one of my favorite tools here that will create a line from a series of points. So I'm going to use this point to line tool. I'm going to grab those survey points, and I'm just going to put it into a temporary line feature class. Now, if I had multiple lines within that survey file, I could break them out by a line field, or if I had a specific sort order that I wanted to follow, maybe a survey point ID, I could define that here. I'm not going to close this line. I'm just going to use the default order of these points. I'll hit run. What it's going to do is it's going to create a line for me. And if I just make the symbology a little easier to see for you guys. I'll turn those survey points off. So now you see I've got a piece of geometry here that represents that new centerline location. And so I'm going to now apply that to these underlying PODS routes. And to do that, I need to get that centerline over into my centerline feature class so APR understands it. Because it's really just in a temporary feature class right now. So again, I'm going to use one of the kind of out-of-the-box tools here. I'm going to select that line, make a copy of it, and then just go ahead and paste it into my centerline feature class. So again, just another way to show you how to get geometry into that centerline feature class from somewhere else. Let me clear that. I can just now remove this temporary line. And now you can see I've got that new geometry in my centerline feature class. So now I'm ready to go. APR knows about this new centerline now, and now ready to use the APR tools again to wire this into the existing network. And so what I'm going to do now is I'm going to use this realign tool. First, I'll go ahead and choose that centerline, and I'll hit realign. And you can see it automatically picks up the begin and end point of the reroute because they happen to be coincident with the existing routes. It's picked up that route name, so it's I'm going to make this reroute effective today. It's going to start on mainline 135. It's going to run to that end measure, and I'm sorry, it's going to run for this begin measure here at 866 plus 78. It's going to end on mainline 136 at 998 plus 502. That's where that tie-in is. I'm going to tell it to take this the stuff that I'm rerouting around and assign it to an abandoned route. In this example, I'm going to pretend this is capped and left in place. So I'm going to need it on my maps for my one call guys. So I'm going to reassign it to an abandoned route so I can still visualize it. I'm going to kick off my reroute at 8679 plus 78, and I'm going to tie in, and this is what's going to create the equation. Let's say at the pipeline measure here is going to be 65. So this is going to be my new station here at the end of my reroute, and I don't want to push that delta downstream. So I'm going to uncheck this calibrate reroutes downstream. If I wasn't maintaining equations and I wanted that new station to continue to roll, I just leave that checkbox, and it would just it would take that delta and move it on and apply it all the way downstream to the end of the next route. So I'll go ahead and run now. So it's telling me, okay, these are the two sections of the original route that are going to be retired. So I've got the original from and to on mainline 135. and this little piece down here from 0 to 998 on this piece over here. So I'm good with that. And now what it's going to say is, okay, I'm going to create two pieces of abandoned route for you, right? Random route one on 135 and 136. And now it's giving me the ability to set the attributes on those abandoned routes. So in this case, what I'm going to do is I'm going to use some of the PODS attribution here for status and identify both of these as historic routes. And I can adjust any of these other attributes as well. So remember, anything that's in the feature class can be edited here in the environment as you pull up. So if I had other attributes about routes that I wanted to manage, they would pop up here. I'll hit run. And now that line's been rerouted around. Let me just turn off some calibration points for you here. So remember I said I have that line color coded. So because it's in a historic status, it'll show it here in the dashed line. I've got the new route running down through this area. If I click on that, you'll see there's the new route ending here at the equation, and then the equation continuing on downstream. You can see if I use that time slider again, very cool. I can just go back to a day or two ago, and I could say, here's what the line looks like with no reroute, and simply slide forward and backwards in history. Now it's here the line as it looks today with the reroute and the equation here at the end of the line. So you'll notice there's 3 calibration points here. You can kind of filter these out based on attributes, but you've obviously got the calibration point for the end of the reroute section. You've got the calibration point on the first point of this downstream route, and you've also got the calibration point that's at the end of this abandoned route here. So if you wanted to turn that one off, you could just turn that off by attributes in the display. But you still got your whole historic stationing on those abandoned routes if you need to go backwards and forwards in time as well. Now, one last thing I need to do, I've done this reroute, but I really need to make sure the system applies all my different rules that I have for linear events. And so if I go ahead and turn on my pipe segment, you'll see just right now, I haven't finished this job yet. So I've still got pipe, the linear event running through this old abandoned section. So what I want to do is I want to apply my rules for all my linear events. And that's just a simple tool that you run from the linear referencing toolbox that says apply event behaviors. And this tracks of all the routes that have been edited. So once I apply that event behavior, it's gone ahead and retired that section of pipe in the rerouted area. So you can see it's broken my pipe on either side. So I now have pipe on either side. And now I would go ahead and add the new pipe ranged event for that rerouted section. And again, it's not really gone, it's just in a retired state. But if I want to see what that looked like before, I can just rewind and see my pipe characteristics, what they look like yesterday, and then go forward in time and see what the status of the line looks like today. So again, I'm using just kind of key out of the box tools. I'm using the location referencing toolbar. I would then now go ahead and add some additional calibration points to this line, and then load in my my additional range and point events along this new rerouted area. So pod 7 out of the box, simple configuration, using out of the box core editing tools to maintain it. So one of the things I had talked about was, not only the ability to do linear referencing, but do a connected model as well. So one of the things that we can now do with the out-of-the-box toolbox is edit that data with the utility network. So some of the stuff that the utility network can do is obviously the mapping components of it, but we can now create connected diagrams. We have a component, our new functionality called containment. We could run trace analysis. We could also model in 3D. These are all some of the new things that are available to you within the utility network. And so what I want to do with the last part of the webinar is show you what that utility network functionally kind of looks like. and how you could potentially use that with PODS as well. So I'll just go back to my demo here. So if we look at a traditional linear referencing system, an APR, this might be what we see for a typical site along a pipeline, right? Where we've got measurements like we've seen, calibration points and routes, but clearly we've probably got more details inside of this facility that we want to manage and model. And traditionally, this connected model or these non-linear referencing features have been very hard to model inside of a linear referencing system. So that's where the new utility network really comes into play, because now we could jump off that linear referencing system, go into more of a connected model inside of this station, trace through all the station piping, also being stored within the PODS infrastructure, and then back out the other side and back onto the linear referencing system, right? And so one of the things that we don't usually have inside of these stations are things like, names, route names. And if we do, we had to make them up. We typically don't have measures. These are all just, or engineering measures. These are all just by pipe length inside the station. And then one of the things that's difficult to do inside of linear referencing is connect all this together. But because I have this all, modeled in the connected model, I can now do things like a connected trace, and I can trace from my linear referencing transmission line inside this station through all this piping, and then back out the other side. So I'll just run a quick connected trace on this model and kind of show you how that looks. So I'm coming off the linear referencing system into this launcher receiver assembly inside all these buildings, and then back out the other side, and then on the downstream side and out that. So now I have all kinds of new functionality that I can enable now that I know how all my PODS linear referencing data, how my non-linear referencing data is all connected together, and do flow and trace analysis and all kinds of interesting workflows with that connected model. We also have the ability to now view this in a different way. So instead of having just this sort of 2D look at what's inside the station, I can take these all and, using some of the utility network functionality, show that in diagram mode. So I'm just using a simple tree view to have an alternate representation of what the pipes look like inside this facility. And these are all connected to the GIS as well. So if I click on this valve here and I apply that, if I select it here and then apply that selection back to my map, everything's tied together, right? So if I move back to the map, it's automatically going to highlight that valve in the schematic as well. So I have this ability to create these P&ID or schematic drawings directly from my PODS data, have this 2D view connected to it, be able to publish those out to the web. Alternatively, I can also view all this data in 3 dimensions as well. So I've just taken these same pipes and thrown them into a 3D view. Now I can see that whole facility in 3 dimensions. I can look at the surface. I can go underground now, see those pipes as they exist underground, or maybe go back and see what this looks like, both in the 2D and 3D model together. So again, these are all those 3D pipes all connected together inside the utility network, and all referenced back to the linear referencing system. And really, the magic here that we're doing, and this is really where we kind of come to the end of our story here, is that we've been able to do this linear referencing networking on its own. We've been able to do the networking or utility network on its own. We didn't do the linear referencing on its own. But now at 10.8, we have these 2 tools combined together. And the way this all gets tied together is that the pipe from the utility network now becomes the center line for APR. So if I'm now able to shut off, say, my station series network and look underneath, you're going to see that pipe layer, that pipe from the utility network is underpinning everything that I have in the geometric, in the linear referencing system. So I create the pipes in my utility network. I then create those as my center line, and then wherever I need linear referencing in my model, I define networks that sit on top of those utility network pipes, and I can add calibration points to those linear referencing systems, and any devices that sit inside the utility network will pick up the measure from the linear referencing system, and vice versa. Any linear referencing objects that I have on my APR can be viewed in the same context as my underlying networks. So I think this is, kind of pulling this full circle. Now at 10.8, starting in January, we can now go from the wellhead all the way down to the customer meter with a fully connected model and be able to jump simultaneously between the linear referencing world and the utility network world and back again, and pick up all kinds of kind of new tools like network diagramming, 3D facility views, and all kinds of different functionality that we've been often looking for in the pipeline transmission space, and sort of borrow that stuff from the utility network and bring that back into the model. So from a PODS perspective, there's a little work yet to be done on the utility network. Right now, PODS out of the box supports APR, as I showed you earlier this morning, but we've got a working group now proposed to PODS to create a PODS asset package for the utility network. And basically what this is going to do is identify things like pipe and all the fittings and all the devices and configure those feature classes for POD 7 into the underlying asset package that the utility network needs. So again, it's more of a configuration versus a redesign or a remodel, but very similar to the way that the APR information model works. The utility network has the same concept, and so hopefully early to mid Q1 or Q2, we'll have a design fleshed out of how that will work. Reason we want to do this in conjunction with PODS is because we've got a lot of customers that have already started down this path, have already started reconfiguring their PODS model to work with the utility network, and we want to give folks a way to get started without having to kind of reinvent the wheel, because we see a lot of folks interested in this this combined modeling technique of bringing these two things together. So with that, I'll turn it back over to Tom for some questions.
Hey, thanks, Jeff. Really appreciate that. We do have a few questions. You were just talking about diagrams there a few minutes ago. There is a question: do you need the ArcGIS schematics extension to see the diagram view?
No, the diagrams are now built into the utility network. So it is the same kind of concept as the old schematics extension, but as you implement the utility network, you automatically get that diagramming tool built into that functionality now.
Okay. Then also on the utility network, a question: does the utility network tie into BIM? Is there a way to bring in the facility piping into the GIS from AutoCAD?
Yep, it absolutely does. So one of the things that we've been doing as part of this sort of journey with the utility network is also working closely with Autodesk and seeing how we can pull in information from Autodesk and make that visible inside of the model itself. So in this, I didn't get a lot of time. I have a more detailed dive that we use for the utility network that if people are interested, I can go into. But one of the things that we've done is inside of this building, to build out this facility pipe inside this building, is we've actually used the BIM file from the as-built as the source. So you can kind of see here where I've overlaid the BIM file inside the 3D view, and then use that BIM file as my guide to place my PODS features spatially, and then fill out all the attributes for that particular, say in this case, valve. So I've got the valve from BIM with its attributes that I can review from the as-built, and then the PODS valve inside the utility network view here as well.
Okay. I think we have time for at least one more question. There is a question about the process of migrating data into the APR database. For instance, in the old PODS data models, we loaded events like pipe segments, valves, T's, etc. by route ID. When we migrate data into the new PODS 7 using the APR tools, it looks like we need to load by engineering or series event ID. You want to tackle that one?
I can. It's actually one of the tools you'd want to focus on for loading data into the model are going to be the append events tool and the load routes tool, right? So to get the engineering routes loaded in here and all the route geometry, you're going to want to take a look at this inside the location referencing toolbox. There's an append routes tool that you want to follow along. And then to load the event data, you'll use this append events tool. And this is really simple to use. You pick your input event, or in this case, let me grab, say, an Excel spreadsheet of these valves. You'll tie to the target event, and then you'll basically map all the fields across. And one of the things that you'll see at the bottom of this tool is an ability to generate event IDs as you load data. So what I'm only going to need to load events is what route and the measure they sit on top of, and then the event IDs for the individual events are automatically going to be generated from the software for you. So you don't have to pre-create those event IDs. The geoprocessing tool will load those into the model for you.
Okay, thanks. Later part of that question, can you talk about the process for migrating Centerlines with M values into an APR data model?
So remember, the Centerline itself doesn't have the M associated with it, right? The M value is going to come from the calibration points. So if I was to go back, this gathering line is an easier example that I can show. So remember, as we built this up, the center line is just the 2D or 3D geometry of where the pipe exists. And then I'm going to add my calibration points where I have known M values. And the result of that is going to be my engineering route that has the geometry from the underlying center line and the M's from those calibration points. So if I was to kind of select on this route here, and let's take a look at the vertices of this route. You'll see those M values are filled in, right? So the M is coming, this polyline M that APR creates is picking up those individual points from those calibration points and making that polyline M measure. And if you want to batch load those calibration points, you can just use the append tool and just move in your locations and your measures into this table. So it has a calibration point measure and a route ID, and then just use the regenerate routes tool to recalculate all those polyline M's based on those new calibration points.
Super. Thank you very much, Jeff. We do have a few additional questions that time is not going to permit us to get to here while we're in this webinar, so we'll follow through separately afterwards to make sure that those questions are answered. Thank you, everyone, very much for your time today. You see Jeff's contact detail right there on the screen, Jeff_Allen at ESRI.com. So feel free to reach out, Jeff, that way. Again, thank you very much for your time and for using our software. We look forward to staying in touch and wish you happy holidays.
Yeah,
Bye for now.
Thanks, everybody. Happy holidays.